Hey everyone, this is Farko Suthar. Today we are continuing with the same chapter, Propositional Logic. Now, in previous two sessions, we discussed what is logic, what is logical connectives, and we discussed almost all the types of logical connectives like conjunction, disjunction, if else, if and only if, negation, contrapositive. Now, in this session, we will discuss examples based on that logical connectives we discussed earlier. Now, question number one, express the following statements in propositional form. The first statement is there are many clouds in the sky, but it did not rain. Now here we want to convert it into the propositional form. So the statement is there are many clouds in the sky, but it did not rain. So first we will convert, or first we will divide it into uh, statements like, let P be there are many clouds in the sky. This is the first statement. But it did not rain. So it did not rain. So here let Q will be it rained. Now the statement is in negation. It did not rain. But whenever we convert it into symbolic form, we always take it in a positive manner. That means if it does not, then we will choose it does. So here it did not rain, so we'll choose it rained. So P is there are many clouds in the sky, and Q is it did not rain. Now in between these sentences there is a but. So we know that but stands for what? It stands for and. So here the statement will be there are many clouds in the sky. So that means P and it did not rain. We have taken Q as it rained, but in the statement it did not rain. So it is negation of Q. So the propositional form will be P and not Q. Second one, I will get first class if and only if I study well and score above 80 in mathematics. So how many partitions will be there? I think there will be three. Let's discuss. Let P, I will get first class if and only if it is a logical connective. Q, I will study well. And third, score above 80 in mathematics. So we have P, Q, and R. So what will be the propositional form? That will be P. Now P, that is I will get first class if and only if. That means we have the symbol this logical connective if and only if. Now I study well and score above 80 in mathematics. So I study well, that means Q. Score above in mathematics, that is R. And here it is end. So we have put here the symbol of end. So the statement will be, so that means the propositional form will be P double implies Q and R. Now next, computers are cheap, but softwares are costly. So here how many partitions will be there? Computers are cheap, softwares are costly. So let P equals to computers are cheap and Q softwares are costly. Now again here but we know that but stands for and. So this is easy. The propositional form will be P and Q. Now next one, it is very hot and humid, or Ramesh is having heart problem. So how many partitions will be there? Just think about it. I think there will be three. It is very hot. Second one, it is humid. And third one, Ramesh is having heart problem. Now, so PQR is there. Now it is very hot. That means P and stands and symbol is we know that and or. So here the statement will be like this: P and Q or R. So that means it is very hot and it is humid or Ramesh is having heart problem. Next one, if I finish my submission before 5 in the evening and it is not very hot, then I will go and play cricket. Now just think about yourself, how many partitions will be there? I am also thinking, if I finish my submission before 5 in the evening and it is not very hot, then I will go and play cricket. So I think there will be four statements. First one, I finish my submission before 5 in the evening. It is very hot. So again, it is not very hot. But whenever we take statements or whenever we take symbols, then we take it in a positive manner. That means it is very hot. Next one, R, I will go, and last S, play cricket. That means I will play cricket. So all we have to do, just combine this PQRS in a symbolic form. So what will be the symbolic form? If I finish my submission before 5 in the evening, so that is P, and so that means that cap symbol, it is not very hot. We have taken Q as it is very hot. So that means there will be not Q. Then I will go and play cricket. I will go, that means R, and play cricket. So that is S. So what will be the symbolic form? P and not Q. And then, so that means this implies R and Q. So that means I will go and I will play cricket. So this symbol. So hence, this is the symbolic form. Now next question. See, if P stands for it is cold and Q stands for it is raining. So we have given two statements. P is it is cold, Q it is raining. Now translate the following in the symbols. The first one, it is cold or it is raining. So we have P, it is cold, and it is raining, so that is Q. So it is the very simple one. Here there is only or. So what will be the symbolic form? P or Q. Yeah, like this, P or Q. Second statement, it is cold but it is not raining. So it is for it is cold, we have P, and but we know that it stands for and. So and it is not raining. Q is for it is raining, but here the statement is it is not raining. So that means there will be not Q. That means negation of Q. So what will be the statement? P and not Q. Yes. Third one, if it is not cold, then it is not raining. We have both negations. So that means not P will be there, not Q will be there, and if then. So that means in between these two propositions there will be implies form. So not P implies not Q. Easy. Next one. Sufficient condition for rain is that it is cold. Now, in previous sessions we discussed this sufficient conditions, necessary conditions. So what will be the statement? Sufficient condition for rain is that it is cold. So what will be it? Whether it is P implies Q or Q implies P. Just think about yourself. Sufficient condition for rain is that it is cold. So it will be Q implies P. Sufficient condition for rain is that it is cold. So it is Q implies P. Now next, a necessary condition for raining is that it be cold. So I think this will be P implies Q. Easy. And next, the necessary and sufficient condition for raining is that it be cold. So here necessary and sufficient both conditions both are there. So this will be double implies or double implication. P double implies Q or P if and only if Q. Next, express the contrapositive, converse, inverse, and negation form of the given conditional statement. The statement is like this: if X is real, then X is rational. Okay, so what we are going to do, first the statement, just convert the statement into the symbolic form, and then we will use all this. So the first one, let P is, here there will be two partitions, X is real, that means P, X is real, and Q, X is rational. Then what is the symbolic form? P implies Q. Here it is only if and then, so P implies that means if X is real, then X is rational. Now the first one, contrapositive. Now what is the contrapositive of P implies Q? We studied in earlier lectures, and it will be not Q implies not P. So whenever P implies Q, its contrapositive statement will be not Q implies not P. Now the given question is in words form, that means in sentence form. So here it is symbolic. So again via symbolic form we will convert it into word form or sentence form. So not Q implies not P. What will be not Q? X is rational. That is Q. Not Q is X is not rational, and same way X is not real. So the statement will be like this: if X is not rational, then X is not real. So this is the contrapositive statement. Now next, what will be the converse? P implies Q. Then the converse is Q implies P. This one is easy. Now in statement form, if X is rational, then X is real. So this is the statement: if X is rational, then X is real. Now, what is the inverse form? It will be like this: not P implies not Q. And in statement form, it will be if X is not real, then X is not rational. Negation form. See, P implies Q's negation. That is, negation of P implies Q. And we are using one property that we will discuss in later sessions. With the property is like this: P implies Q. It is the symbol is logically equivalent symbol, and we will discuss in next session too. So this not of P implies Q is logically equivalent to not P or Q. Okay. So therefore X is not real or X is rational. Next one, construct. Now these type of questions may also ask. Construct truth table for the form not P or Q implies Q. Now it is very easy. Now first just look at the statement, and according to that we will add columns in the truth table. So there will be the first, P will be there, Q will be there. Okay, P will be there, Q will be there, not P, then Q is already there. Now this portion is not P or Q, and the last one, this whole statement. Now there are only two statements, so that means we have four possibilities. Either both are true, both are false, one is true, another one is false, and first is false, second one is true. Now what will the call in column not P? Here TTFF is there, so that means the negation. So FFTT. Now not P or Q, so that means this both. So TF, what will be this? Or. Or means whenever one is true, the whole sentence would be true. So here TF, that means T, both are false. So false, both are true, so then true. And any one is true, so that means it is true. Now the implies, that means this implies Q. That means second one and fourth one. Now in what is in conclusion portion Q. So both are true, then it will be true. Now both are false, so again it will be true. Now both are true, so it will be true. And this T implies F. So in conclusion part it is F, so this will be F. That's it. This is a truth table. Now for three statements, construct the truth table for the form not P implies R and P double implication Q. So how many columns will be there in the truth table? First, P, Q, and R. They are all will be there. Then not P. Okay. Then not P implies R. This one. Then P double implication Q. And the last one, the whole statement, this. Now, there are three statements. Then how many possibilities will be there? For two statements, there were four possibilities. Now for three, there will be eight possibilities. Like this. Now, how to choose this? First, fix these two entries. That means both are true. So there will be two possibilities. Either it is true and either it is false. So these two are done. Now again, fix T and F. So here there will be two possibilities, T and F. So TF, first is true, second is false. Now fix FT. So FT. So here there will be two possibilities, T and F. And last, fix 2F. That means both are F, FF. So here there will be two possibilities, T and F. Now for not P, negation of this column. So T, 4T, 4F. So what will be the negation? 4F, 4T, like this. Now not P implies R. So that means this both. Now the conclusion part is this. What will be not P implies R? Here, both are different. So consider this. So it will be true. Now both are same, so it is true. Here both are different, so this portion, so T. Both are same, so true. Both are same, true. Both are different, so consider this, so false. Both are same, then true. Both are different, consider this, so false. Now, the double implication Q. So consider these columns. So whenever both are same, then it is true, otherwise false. Here both are same, so both are true. Here both are different, so false. So these four entries will be false, like this. And last two, both are same, that means both are false, so it is true. Both are true. Now and. So that means these two columns and in between there is and. So what is and? If both are true, then true, otherwise false. So both are true, so true. Both are true, true. Both are different here. So all four entries will be false. Here both are true, then true. Both are different, then false. Okay. Thank you very much.